First property, opposite sides congruent. Got it. Next. 6. Ooh. $19. Garbage. 16. Garbage. 3. Okay, this is painful. How many diagonals are in a parallelogram? 2. And what do they do to each other? Okay. Bonus. That is the what of each of those 2 diagonals? Oh boy, yikes. We're in trouble tomorrow. That is the what of both diagonals. That is the midpoint of both diagonals. Everybody good? Speaking of diagonals, I meant to do this with the homework. Oh boy. Here you go. Whoa, whoa, whoa. Here you go. Go back to my example here that I went over with you guys. Quick question for you. Is that a diagonal I just drew in? So is AC getting bisected? Is AC getting bisected? No. Not unless both diagonals are drawn in, and that orange line certainly is not a diagonal. Okay, next property. Good job so far. Good job. Next property. 11. Yes, they are. And I believe there's one more I'm looking for. One more property. Oh, 14. There you go. Nice job. Consecutive angles are supplementary. I'm not going to put that one up there, but we can use that in an algebra problem. All right, so here we go. So those are all my properties going into tomorrow's quiz. Today, I'm going to flip the script on you. What I'm going to do today is this right here, that it's a parallelogram. You got to prove to me it is now. Okay? The way you prove, now you look on your notes, everyone see you got 5 different ways. The first 4 are the properties. Take a look at my parallelograms. You make your parallelogram look like one of these, you're done. If you can make your quadrilateral look like this one here, it's a parallelogram. Maybe you can't do that. Maybe you show opposite sides are congruent. It's a parallelogram. You don't need to show all 4 at the same time. You just need to show one of these diagrams. Now you'll notice I have one blank in the middle because there's an alternative way to prove it's a parallelogram. Go ahead and read number 5 for me on your chart. Read number 5, the 5th way to show a quadrilateral is a parallelogram. And that is if you take one pair of opposite sides and show them what? If they are parallel and the same pair are congruent. All right, I refer to this as you'll hear me say the special case. Now, are you allowed to write that in your reasons? Absolutely not. Okay? Oh, it's a parallelogram, reason, special case. No. All right, but this is the 5th and alternative way of proving it a parallelogram. All good? All right, you are not ready for a proof yet. Sorry, kids. So what I'm going to do is bare bones basic. I will give you a piece of information. Is it good enough to say that quadrilateral is a parallelogram? Here we go. First one, SPX, find that angle, is congruent to TMX, find that angle. So those 2 angles are congruent. I don't know if anything's churning in your head right now, but since it's December 16th, I hope something is. All right, if you know those 2 angles are equal. Also, I'm going to give you TPX, congruent to SMX. Knowing that info right there that I've marked on mine, is that good enough to say this is a parallelogram? Is that good enough for one of those diagrams? That's what I'm asking. So let me start here, because I said it's December 16th, and by this point in the year, hopefully something's in your mind. Remember the gray angles I just put up here? If those gray angles are congruent, what's in your mind right now? Here we go. 14, what type of angles are those? Which means I got to have a pair of parallel lines. What are the lines, Emma? Okay, so SP, everybody, is parallel to MT. Got it. Because those are alternate interior. What about my other pair that I marked? 8. What type of angles are my yellow ones up here? Great. Good job. 11. So if they're congruent, give me a pair of lines that should be parallel. Is that a parallelogram? Yes. So this is enough information. But of course, you always have to explain yourself. And this is what we're going to start writing in the reasons column. Remember what we wrote? Parallelogram implies whatever? Flip it now. Flip it. What property am I showing up here right now? Oh, yeah, 14. What property am I showing? On fire today, Emma. Let's go. Opposite sides parallel. So we're going to write that first and now say it implies a what, kids? Parallelogram. There it is. Questions? Yes. Correct. One pair is not going to cut it. One pair is not going to cut it. It's got to be both pair. All right. What about this next piece of information in number 2? Ready? SX is congruent to XT. Got it? And SM is congruent to PT. Is that enough to say it's a parallelogram? I don't know. Is it one of those diagrams we were throwing up at the beginning of class? Is that good enough? Those markings alone, is that good enough? 4, is that good enough? No, you need more. So as of right now, that's a no. You need more. Everyone good? That's not diagonals bisect each other, and that's not opposite sides congruent. It's nothing. Nothing. All right, what about the next set of info? What do we got? PX congruent to MX, SX congruent to TX. Good enough or not? Good enough? 10, good enough? Yeah, it is. What property is being applied here? Diagonals bisect each other. Imply I have a parallelogram. Yeah, I love it. And ready for the last piece of info. Let's get rid of this. Going to start from scratch. SP is congruent to MT. And also they tell us SP is parallel to MT. Good enough or not? Good enough or not? 2, good enough? Yes, this is my alternative, AKA special case. But I just don't write yes, special case. What's given there? Because wording is important to me on this one. Okay, ready? 1. Don't just say pairs or both pair. 1 pair of okay, you have to have the word opposite. Because when you say 1 pair of sides, it could be any pair. But they have to be opposite. 1 pair of opposite sides, congruent, and parallel. Got to be the same side. Whew. All right, kids, you good? All right, show me you're good. You got some little something, something on your own coming up here. There we go. If you're going to tell me yes, write the reason. If it's no, just write no. All right, go ahead. 7 through 14, is it a parallelogram? If your answer is yes, reason. If it's no, just fine. #21, number 7, parallelogram or not? Why? Each other. Yes, thank you. Diagonals bisect each other. Good. How about 8? Was that a good parallelogram? 11. No, needed a lot more than that, right? How about 9? Look at all those crazy markings. 9 for 9. Nope. Maybe if I take that hash mark to the left and put it on the bottom, we'd be good, but not right now. Here we go. Question 10. 3. Yes. Thank you, Riley. Great job. And how about 11? Ooh, 11. 2. Not alternate interior angles and congruent. What's the alternate interior angles give you? Whoa. We're just spitting out stuff now. The alternate interior angles mean the lines are parallel. So your reason's going to be opposite sides parallel imply a parallelogram. All right. Alternate interior angles being congruent is not a reason for a parallelogram. All right. 12. Here we go. Question 12. 18. Yeah. The property's what? What? Both. Thank you. Both pair. Not one pair, both pair. So that's why that's a big no spot. How about 13 here? 19, not here. Great. Good talk. 21. You did. Why? Perfect. And how about question 14? Number 5. Nope. Need a little more. Whew. Are you ready now to go to the proofs? Do you think you're ready? Let's find out. Mark your diagram. You're welcome. The given's already in there for you. Mark your diagram. No, it's not. All right, here we go. A lot of chatter going on. I like it. This one's not too bad, I hope. First thing I got to emphasize. In the givens, what does it say PQRS is? A quadrilateral, meaning it has 2 properties only. It's got 4 sides, interior angles add up to 360. That's it. Don't tell me quadrilateral implies opposite angles congruent. No, stop. Quadrilateral basically has 0 properties that are useful for you. Okay? But I am given 1 congruent to 2. Let's stop there. December 16th, remember, 1 congruent to 2 should conclude something for you right now. If 1's congruent to 2, then 3. They are. And if they're congruent, what lines? There we go. PS parallel to QR. I realize it's been a while since we used this reason, but anybody want to take a shot at why they're parallel? Let's go, Jack. Oh, first honor student today out of the 3 classes to say alternate interior angles congruent. You don't put the congruent in there, that's a false statement. Imply parallel lines. Got it. PS, QR, parallel. Nice, nice. Hey kids, what about 3 and 4 being congruent? What about 3 and 4? What's that conclude? 14. 3 congruent to 4 means PQ, parallel to SR. Got it. And I'm just going to put it in the same statement because it's got that same reason. All right, take a breather here. Look at what we've got. Look at your markings on your diagram. What is this right now? It's good enough. This is good enough right now. to say PQRS is a, and you know how I feel if you're here on Friday about that symbol, parallelogram. Not off the hook yet, honors kids. What's the reason? 9. What's my reason? Nice. Yeah, like it, like it. Everyone else comfortable before we get to the next one? Because as you know in here, they increase in difficulty. We okay here? All right, here we go. How about this next one? Ooh, how about this? You're given a parallelogram and got to prove a parallelogram in the same darn diagram. Woo! All right. AE congruent to CF. The entire figure is a parallelogram. So any of your properties you can apply only to ABCD. Only to ABCD. You can apply any parallelogram property. And we need to get the inside quadrilateral to be a parallelogram ourselves. Okay? We need to get that one to be a parallelogram. So can we start with ABCD being a parallelogram? Any properties you want to throw out there right now that might be able to help us here sooner or later? Any properties? Here we go. Just throw it on out. Anything. 14, throw it on out. On fire, Emma. So you want to do both pair? Or just one pair? It's up to you. Okay, don't you keep going. I'm just going to put DB, DC congruent to AB. True statement from Emma. Parallelogram implies opposite sides congruent. Yeah. Okay, you're going to keep building with Emma now. I'll take anything. Just keep building with her proof here. She gave you AB and DC congruent. Would you like to go next? Maybe? Oh boy. 6. Patrick with the subtraction. Now, hey, I got to start harping on you guys a little more because you drive me nuts when you use subtraction and addition. If we're going to use subtraction, what I'm subtracting, do you have it all equal to each other? Before I write down subtraction, what I'm about to subtract, are they all equal to each other? Yes. You got DC and AB, you got AE and FC. We're good. If you find yourself writing subtraction or addition, please make sure that everything's equal. So DC minus FC is equal to AB minus AE. Subtraction. Nothing changes. Now I'm just going to substitute in what they're equal to, which is EB congruent to DF. Substitution. All right, nice job, kids. 1, 2, 3. 1, 2, 3. So it looks like you guys have one pair of opposite sides congruent, right? Okay, here's where I'm going to ask now before we start getting nuts. What else would make it into a parallelogram now? In addition to this, the opposite sides being congruent, what else would make it into a parallelogram? Because we could go 2 ways right now. 2 different ways we could go. We could do this and it would be a parallelogram, or we could do this and it's a parallelogram. Jack, one thing. So you could prove the congruent sides parallel. We could try that. All right. Or we could prove what about the other pair? Congruent. So we have 2 ways we could go right now. All right. I could prove this pair that we just proved congruent parallel, or the other pair congruent. I'm just leaving it out there. Whoever I call on next, I guess, is going to dictate where we go. Okay. So does everyone see our options right now to finish this proof? Okay. Where are you going next then? 6 again. All right. About 95% of the kids in here, Patrick, are like, oh, why did he do that? But I love it. I love it. And really, my opinion is the only one that counts. DC parallel to AB. Because I'm assuming most of you would have went for the FB congruent to DE route, which is fine. I'll do it at the end. Parallelogram implies opposite sides parallel. And I love that Patrick did this because this gets me into a new theorem that you can use from now on, which I think a lot of you will like. But I got to do a magic trick first. Here are my two lines. I will let you know that they are parallel to each other. Okay? Everyone good? Those are parallel. Just go with it. Are those two parallel? What about those two? Those two? So if DC and AB were parallel, what else should be parallel then? DF should be parallel to A or EB. This is a new theorem now that we can use in these proofs, which says parts of parallel lines are parallel. Okay? If the whole things are equal, or the whole things are parallel, so are the parts. So are the parts. Okay? Do I have a parallelogram now? Let me mark this. We just proved those. Is that a parallelogram now? Yes, it is. Here we go. What's it? EBFD? Is that right? EBFD is a parallelogram. What's the reason why? 19, not here. Great job. 12, reason that's a parallelogram. Not here. 12, nope. I'm on my game today. 8, and I guess I'm not on my game. I would have known that, right? Karma. 7. Perfect. Implies parallelogram. Okay. Let me go back to the other 95%. Were you guys that were going to try to prove these two sides congruent? Were you going to prove the two triangles congruent to do CPCTC? Yes? Okay, that's the other way of doing it. All right. So let's go and write our new theorem down so we have a place to see it and view it all the time. And that says if the whole things are congruent, parts of parallel lines are parallel, yep. Now I have a theorem 2 in there. Throw this scenario at you now. Now the one inside is a parallelogram. So you know those are parallel. Can I still say the longer parts are parallel? Can I still say that? Is that still true? Yeah. But instead, if you're going to go shorter to longer, we have to say Gracie, extensions of parallel lines are parallel. Now, every couple of times I get a chuckle out of some of what kids write down and say. You know, I actually become a human being with a heart and not just a machine. Do not put in the word congruent. Okay, parts of congruent lines are not congruent. I hate to break it to you. All right, that's embarrassing. Kellen's looking at me like I have 5 heads. Yeah, that's what I look at the paper too. All right, when kids tell me, oh, parts of parallel lines are parallel. Really? Really? Okay. Good, good. No, it's just only for parallel. All right. Questions? Quiz tomorrow. We good? Okay. Get rolling on that homework for me.